linear inequalities in one variable will be your first type that we are going to do, that we are going to discuss today, which you have already done in your class 10. Next will be linear inequalities in two or more variables. Just like you have simultaneous equations in two or more variables, you have linear inequalities or linear inequations in two or more variables. Out there, two inequalities or three inequalities will be given to you. Okay. And finally, you have quadratic inequalities in one variable, where the power of the variable is 2 in one variable. These three we are going to discuss under inequalities. Okay. So let us start with the first one, linear inequalities in one variable. This is just a revision of what you have done. See the first question. The question said, find the range of values of x which satisfies. So you're given here is minus 2, 2/3 less than or equal to x plus 1/3 less than 9 1/3. And you see you must have a replacement set. The replacement set here is x belongs to R. Now remember, unless otherwise mentioned, okay, unless otherwise mentioned, you will always treat the replacement set as a set of real numbers from now on. Okay. Even if the replacement set is not mentioned, even if this part is not mentioned in the inequalities, you will treat it as if x belongs to R. Okay. So keep that in mind. So here we are going to split this inequality into two as we used to do. You have minus 2 2/3 less than or equal to x plus 1/3. And this is x plus 1/3 less than 9 1/3. So now we are going to solve this. This mixed fraction is changed to improper fraction, minus 8/3 less than or equal to x plus 1/3. So now this becomes minus 8/3 minus 1/3 less than or equal to x. That means this is minus 8 minus 1/3 less than or equal to x. That means this is minus 9/3 less than or equal to x. That means minus 3 is less than or equal to x. That means x must be greater than or equal to minus 3. So you know all these rules of reversing the inequality sign and all. Okay. Next one here, if you want to solve this again, x plus 1/3 less than, this should be 28/3. Means x is less than 28/3 minus 1/3. That means x is less than 28 minus 1/3. Means x is less than 27/3. That means x is less than 9. Okay, now if you remember, as I told you back in class 10, that you're getting two solutions, right, of two different inequalities. So what should be the solution set of this? Say the solution set of this is A. We write x such that x greater than or equal to minus 3, x belongs to R. This is the solution set of this. And what is the solution set of this? X such that x less than 9, x belongs to R, isn't it? This is the solution set. Both are infinite sets. So therefore, what should be a solution set of the given inequality? The solution set of the given inequality will be the intersection of these two sets. Therefore, solution set must be equal to A intersection B. Now, what is A intersection B? X is less than, x is greater than minus 3. So x such that X is greater than or equal to minus 3 and X is less than 9. X less than 9. X belongs to R. That means X lies between minus 3 and 9. Right? This is what I told you, if you remember back in class 10.
Yes, sir.
Now, how do you graph this solution set? There's 0. And I'm not going to draw all the points. Simply draw what points are given here. Let's say minus 3 is somewhere over here. And let's say 9 is somewhere over here. Okay. So since you have an equality with minus 3, we'll give a vertical line here. And since you don't have an equality with 9, we'll give a curved line, uh, line here. And we are going to join it. That is, all the values between these are the solutions of this inequality. Right? This is the way I told you. So this completes the solution of the first one. So this all you have already done. Okay, you won't get any question from this. This was just a revision. Okay, we'll do the next one. The next one here is solve the following system of inequations. Now, whether I say inequalities or inequations, it's the same thing. Okay. Now, system of inequations. System means more than two inequations. Okay. More than say 3 inequations. The entire 3 inequations collectively is called a system. Okay. So the given inequations are twice 2x plus 3 minus 10 less than 6 times x plus 2. And you have 2x minus 3 by 4 plus 6 greater than or equal to 2 plus 4x by 3. You solve them individually. Okay. Solve the first one. Just as you were doing earlier, we are solving 2 inequations. Here also we solve them individually. Okay. 22 minus 6 is how much? It's 16. Yes, that means now we need to divide both sides by minus 2. So therefore the inequality sign will reverse. Okay. So we're getting x greater than minus 8. Also, we'll start with the second one. The second that was given to you was this inequality was given to you. So solve this. Let me first, before writing this, let me first state 2 very important things. First thing here, see that the replacement set is not given, right? So as I said, if the replacement set is not given, you will treat the replacement set as real numbers.
Real number.
Okay. And once you solve the first inequality, you're going to write down the solution set of this. Okay. What should be the solution set of this? X such that x greater than minus 8, x belongs to R. This is the solution set. Now we start with the next one. So x less than or equal to 3.9 we are getting. So what should be the solution set of this? Right. So now both the inequalities together. What should be the solution set? Solution set of the first one is A. Solution set of the second one is B. So the solution set of both the inequalities will be A intersection B. So let's write, therefore, solution set is equal to A intersection B. Let's write down the sets. What was the first set that we got? X such that X is greater than minus 8. X such that X is greater than minus 8. X belongs to R. Intersection X such that X less than or equal to 3.9. X belongs to R. Okay. Now, what should be the intersection of these two? X is such that X is greater than minus 8. And also X is such that it is less than or equal to 3.9. Right. So what should be the solution set of this? Let me check the first one. This was a minus sign here. All this will be minus. That's why something you have changed it accordingly. So this was a minus sign, 6x minus 12. So you have a minus 12 here. Minus 12 plus 10 minus 6. So this will be 10 minus 18. It's minus 8. That means you get if minus 2x is less than minus 8, that means 2x You want to divide both sides by a negative number, isn't it? But inequality sign is going to reverse. So x greater than -8 by -2. That means x is greater than 4. So your solution set will be x such that x is greater than 4. X belongs to R. Okay, now let's see the solution set here. So we have x such that x greater than 4 for the solution set of the first inequality. Now what should be the intersection of these two? See, x is greater than 4 here and x is less than 3.9. Is it possible? Can x be greater than 4 and can x be less than 3.9 at the same time?
No, sir.
It is not
Not
possible.
possible.
Therefore, the solution set is a null set. Clear with this? We'll move on to the next
Yes.
one. Number 3. Question is solve the following inequalities. Now, before I start solve these inequalities, first I would like to explain something called as the modulus of a number. Modulus, or also called as the absolute value of a number. Okay. Now, modulus of a number means suppose I have a negative number, say -3, and I take the mod of this. The mod of this is represented by two vertical lines on either side of the number. So this is called modulus of modulus -3. Okay, or simply mod -3. Now, what do you mean by modulus -3? Whenever we have modulus -3, modulus of a number is taken, it converts the number to a positive number. Okay, when you take the modulus of a negative number, it converts the negative number to a positive number. But how is it converting? It is converting in this way. See, the number inside here is -3, right? So what it does is that it takes a negative sign, that is right, and this -3 it takes with this negative sign. So it becomes minus of -3, which is +3. Okay, this is what it does. For a positive number, let's take modulus of 5. Modulus of 5 is simply 5. It cannot, because it is already positive, right? So that is what modulus or absolute value of a number means. Now, what do you mean by modulus of in a equation or an inequation? Let's say inequation for that matter. Let us say that if we take mod x is greater than 3, let's start with a less than or equal to. Suppose if mod x is less than or equal to -3, it means that x must lie between -3 and +3. Understood? So if given this, you must be able to write this directly from here. Okay. Also, if I give you mod x is less than, say, 2 without the equality, then you will write the same thing without the equality. 2 less than x -2, sorry, -2 less than x less than +2. That means x must lie between -2 and 2. Remember this rule. Okay. Also, if I have mod x, say if I give you greater than or equal to 3, this time I have reversed the inequality sign. Then what can you write? If I have mod x greater than or equal to 3, then you can write x must be less than -3 and x must be greater than 3. Okay. Similarly, if you have mod x is greater than 5, what can you write? What can you write?
-5 greater than
X is
smaller than minus
X is less than minus 5, not greater than. X is less than minus 5, X is greater than 5.
Yes, sir.
But
Okay.
sir,
Yes.
sir, x will give only positive sign now because there is modular.
See here, here I have positive sign on the right hand side. But what are we taking? We are taking a minus 3 and a plus 3. Here we also have a positive. So what are we taking? We are taking a negative sign and a positive sign, isn't it? Here we have a positive. So we are taking a negative and a positive that way. Understood?
Okay, sir.
So this rule you must remember, okay, before we proceed with the inequalities with mods. So now we'll start with the first inequality that I have given you. The first inequality here is mod x minus 3 less than 4. That means what does this mean? According to a definition that I gave you, that means minus 4 less than x minus 3 less than 4. Yes.
Yes, sir.
Sir.
Now this inequality can be solved. You split it into 2. Minus 4 less than x minus 3 and x minus 3 less than 4. So this will be minus 4 plus 3 less than x. That means minus 1 less than x. That means x greater than minus 1. And here also x is less than 7. So what are the two solution sets you are getting? A is equal to x such that x greater than minus 1, x belongs to R. Because replacement set not given, we'll consider it to be a real number. So x such that x less than 7, x belongs to R. So what should be the intersection of these two sets? X such that now x is greater than minus 1 and x is less than 7. That means x must lie between minus 1 and 7. Clear? This is how we solve this
Yes, sir.
inequality.
Yes, sir.
We proceed with the next one. Question here is twice mod 3p minus 5 greater than or plus 1 greater than 7. Okay, so what we do here is first take this as twice mod 3p minus 5 greater than 7 minus 1. That means you get twice mod 3p minus 1 is greater than 6. That means you get mod 3p minus 1 is greater than 6 by 2. Means mod 3p minus 1 is greater than 3.
Sir, 3b minus 5.
Yes, 3p minus 5. So you have 3p minus 5 and here 3p minus. Now if mod 3p minus 5 is greater than 3, that means this must lie between 3p minus 5 must lie between minus 3 and plus 3, isn't it? Oh, greater than.
Yes, sir.
Not, no, this is greater than. It cannot lie between. That means you can say that 3p minus 5 is less than minus 3 and 3p minus 5 is greater than plus 3, right?
3.
Because there's a greater than sign. So we'll solve this. 3p minus 5 less than minus 3, 3p minus 5 greater than 3. So this is 3p less than 5 minus 3. That means p is less than 2/3. And here you have 3p greater than 8. That means p must be greater than 8 by 3. So that, what are the solution sets? Solution set for this is a is equal to p such that p less than 2 by 3, p belongs to R. What is the solution set here? P such that p greater than 8 by 3 and p belongs to R. So what is the solution set? A intersection B. And what should be the intersection of these two sets? What should be the intersection? P is less than 2 by 3. P is also greater than 8 by 3. That means, is it possible that P can be less than 2 by 3 and can be greater than 8 by 3?
No, sir.
Yes. Intersection P is less than 8 by 3 and P is greater than 8 by 3.
No, sir. I don't.
Just let me check if I made a sign mistake. I should not come to a null set. Have I copied the question correctly? Twice 3P plus 1. Yes. Yes, this is okay. So okay. So this is P is less than 2 by 3 and P is greater than 8 by 3. That means if both inequalities cannot be satisfied together, that means this must be a null set. This is okay. Okay, solution set is a null set. Moving on to the next one. To very quickly finish this, and then before moving on to the next part, I want to explain something that is very important for you, which you want to know before doing the inequalities in two variables. So given here is 5 minus mod of 5 minus m minus 3 plus 8 less than 15. You can write this as mod 5 minus m minus 3 less than 15 minus 8 is 7. That means, what does this mean? That means minus 7 less than 5 minus m minus 3 less than plus 7. Can write this way from the definition of mod.
Yes, sir.
Yes, sir.
Now we split this into 2 and we solve them individually. Minus 7 less than 5 minus m minus 3. And this is 5 minus m minus 3 less than 7. So you have m minus 3 less than 5 plus 7. That means m minus 3 is less than 12. That means m is less than 15. And here you have 5 minus 7 is less than m minus 3. That means minus 2 is less than m minus 3. That means minus 2 plus 3 is less than m. That means 1 is less than m. That means m is greater than 1. So what is the solution set here? A is equal to m such that m less than 15, m belongs to R. What is the solution set here? M such that m greater than 1, m belongs to R. Right? So what should be the solution set of the given inequality? A intersection B. And what should be the intersection of these two? M less than 15 and m is greater than 1. That means m such that m must lie between 1 and 15. Yes?
Yes, sir.
Yes.
So that is the solution set. This is how we treat the modulus value problems. Okay, now I want to start something that is very important before going on to the next section. And this part is very important. This part deals with a little bit of coordinate geometry, which you have already done in your class 9. You know, if I give you two simultaneous equations, you know how to graph a straight line. Suppose if I give you two equations, let's say if I give you x minus 2y is equal to 8. Okay, this equation I give you, and say if I give you another equation 2x minus 5y, let's say plus 5y is equal to 10. Okay, now if I want you to draw the graph of this, how will you draw? You will take x and y, isn't it? And you will first write this in the you'll first write this first equation, x minus 2y is equal to 8 as y is equal to x minus 8 by 2, isn't it? And then you will take x and y, isn't it? This is what you have been doing, isn't it? Remember your class 9, and then
Yes,
you
sir.
were getting these points. You take 0 first, then you were getting say minus 4, then you get the point 0 minus 4, you plot the point 0 minus 4, and then you draw a straight line, and similarly you get 3 points like this, right? But here we'll learn a little more sophisticated way of drawing a straight line. Okay, now how we'll draw, we'll do this again when we'll be doing straight lines, but for the time being just know the working rule of this. So from 1 you have x minus 2y is equal to 8. What you will try to do here is you'll try to make this 8, convert this 8 to a 1. So what you'll do is you'll divide both sides by 8, right? So what you get here is x by 8 minus y by 4 is equal to 1. So we have converted this side to 8. Now we convert this minus sign to a plus sign. So x by 8 plus, now you can write this as y by minus 4, isn't it? Is equal to 1. Yes, you can write this in this way.
Yes, sir. Yes.
Now, once we have converted this 8 to a 1, and once we have converted this minus sign to a plus sign here, now see below x, what do I have? A plus 8, right? So now
Yes, sir.
it will be very convenient for us to draw the straight line. See how? This 8 here plus 8 here means the x-intercept is 8. That means you take 8 units here. That means this point is your 8, 0. Understood? This minus 4 here means the y-intercept is minus 4. That means you will take point minus 4 here. Understood? So this point is your minus 8. You understood this part,
Yes, sir.
right? So just because below x I had an 8, so I took an 8 here, plus 8 in fact, not minus 8. This should be a plus. Okay. I took a plus 8 here, and because below y I had a minus sign, I took a minus 4 towards the negative side. And now what I'm going to do is I'm going to join these 2 points and form a straight line. Is that clear?
Yes, sir. But
So,
sir,
tell me.
sir, if there would be a negative sign in between x and y, then it would be possible.
Yes, still possible. Like what? Can you give me an equation?
Sir, x by 8 minus y by minus 4, then
Plus y by minus 4 is equal to 1, right? But this is
no,
the
sir,
form.
no, sir. X by 8 minus y by minus 4.
Okay, minus y by minus 4. So if you have minus y by minus 4, then this you can write as x by 8 plus y by 4 is equal to 1. So you still have a plus
Yes,
sign here.
sir.
That's it. Okay, so if you want to draw this kind of a line, then how will you draw? You have 8 here, so this point will be okay. And 4, you take in the positive side of the y-axis. So this is your 4, or coordinate is 0, 4, right? And now you join this. Is that clear?
Yes, sir.
Next, look at number 2. You want to draw the straight line for number 2. 2x plus 5y is equal to 10. So let me do here. Let me just erase this. I just have 2 minutes left. 2x plus 5y is equal to 10. 2x plus 5y is equal to 10. We want to make this 10 1. So we divide both sides by 10. So 2x by 10 plus 5y by 10 is equal to 1. So I already have a plus sign, nothing to do here. So I get what? X by 5 plus y by 2 is equal to 1, isn't it? So now how will I draw this? Below x, here I have a positive 5. I'll take say 5 here, right? And below y, I have a 2, positive 2. So 2 is say somewhere over here, right? So this is your coordinate 0, 2, and this is your 5, 0, right? And you join these two to form your straight line. Clear with this?
Yes, sir.
Yes.
We'll be using this to draw straight lines when I'll be discussing linear inequalities in two variables. Okay, so just remember this concept, and I will not explain this once again tomorrow. I'll be directly applying this method tomorrow. Okay, so linear inequalities in two variables, the questions I'll be sending you today. Fine. So we'll continue next week. Thank you.